And welcome to this presentation on the concept of digital twins. My name is Nate Miller. I'm the founder and CEO of a company called Proving Ground. And if you're kind of new to our webinar sessions, I'll just briefly introduce what we're about. Proving Ground is a digital design agency that helps architects, engineers, builders, and owners implement data strategies to support decision-making. And while this involves many technology concepts, one of our central beliefs is that we need to be able to balance the availability of technology and the capability of new data with human-centered strategies that can really enable people to adopt new workflows and ultimately make better decisions about the built environment. So what you'll hear in this presentation about digital twins is a narrative about this technology concept that is growing in popularity, the tools that are used to enable this technology concept, but we also want to bring it back to what it means to compose the digital twin in a way that makes sense for people and their process. And one of the central observations that we have about building design and construction is the kind of complexity and the challenges in wrangling data and information on any given project or business. When we look at the state of the building design and construction and operations world today, we can observe that any given project or building will produce a deluge of data. Some of this data is useful. Some of this data is, not exactly useful. And so there's this challenge in sort of parsing that all out. And professionals have to negotiate with numerous disconnected sources of data. It's a major source of friction in coordinating and creating kind of more holistic and homogenized views of this information. And when we think about the emergence of other data sources as our buildings and our facilities become smarter, we have things like the Internet of Things and sort of real-time dynamic data feeds about these buildings, and just adds another dimension of kind of wrangling and producing meaningful views of this data over time. So that brings me to this topic of today, which is the digital twin. The concept of the digital twin has come into fashion in recent years in building design and construction, and the idea has its origin in places like manufacturing, wherein you have the adoption of product lifecycle management tools and feature-based modelers and kind of the understanding of a product from design into kind of production and use, right? But I think it's fairly new to talk about the digital twin in the concept of kind of the architecture world and buildings and operating buildings and making them. So there is this sort of high-level technology concept in play here, and it might, the idea of digital twin might evoke all sorts of mystery and intrigue. It's kind of a fascinating combination of words, right? And I certainly wouldn't want to encounter a digital twin in the hallway of a secluded hotel anywhere. But one of our goals is to kind of make this concept maybe less mysterious and less scary, perhaps. So what is a digital twin? A digital twin refers to a real-time digital representation of a physical object, environment, or process. The idea is to provide, ultimately, to use this kind of asset to provide users of a physical object or environment with data about how that object is performing in real time. So, if you need to make adjustments or take action in some way, you can do so by learning from the data that's available to you to guide those decisions, or potentially enact automation that can respond to those decisions as that kind of digital physical feedback loop occurs. Now, if you are new to this concept and you hear it mentioned in a lecture like this one, you might hit up the internet and look for articles or images to help guide you to understand what a digital twin is. At the moment, there is quite a bit of hype around digital twins. And even as I was putting together this discussion today, I was looking for some, practical content to show, and kind of give some context to what's out there. And one of the conclusions that I came to is that it seems to be quite fashionable to produce Photoshop graphics that show, some dude holding or pointing to a digital wireframe somewhere. And, I challenge you to do a Google search on digital twin and kind of see what's out there. Some rather hilarious, in my view, from a nerdy kind of technology standpoint, some hilarious trends and in what's out there from a digital twin marketing standpoint. And so one of the dangers we often point out to our clients is that the reality behind a new technology concept is quite different than what the marketing might imply. So today we have a lot of chatter about digital twins, but the work related to practical implementations and tactics and the how for a business is still kind of, in many ways, I think, a challenge to suss out if you're kind of being self-guided on the concept. And in our company at Proving Ground, we're very much interested in, formulating kind of tangible examples rather than kind of relishing in the vapor, so to speak. So what I'm going to do is really kind of follow that trajectory a bit and hopefully provide some interesting anchors for everyone. And this will be leading up to a practical example that we've composed, explaining what this can be and what it can do. But I'm going to maybe continue on with the meme here a little bit and show some icons and arrows in Illustrator to articulate the kind of simple tenets of this concept. So a digital twin kind of refers to this idea of a physical digital connection. You have a physical object in the real world. Might be a building, it might be a part, it might be an airplane, it might be a road or bridge somewhere. But the idea is that this physical object has systems in place that can report on its current state. It might be sensors, it might be building management systems, it might be other kind of enterprise systems that are being used by the building. But the idea is that this is off-gassing or outputting some kind of digital output, right? And so this digital output can be composed, and what the digital twin refers to is that it's sort of the coherent assembly of the object's digital data. It starts to allow us to understand and monitor the sort of state of the physical object with digital data. And it is primarily composed by data streams. These data streams are composed, they're curated, they are then used to basically paint a picture of the state of the physical. And then this picture that we're given, that we compose with the data, can be used for some kind of feedback or form of optimization to improve that physical product. The feedback between the digital and the physical is essential here. And there might be, different forms that it might take. There might be kind of a softer form of feedback, which might mean that, hey, I'm a user of this building or a manager, and I'm looking at a report and I'm seeing something in the data that's guiding me to some sort of decision. So I'm gaining some kind of new insight from the data. Or the occupant is able to sort of look at the available information and take action on it in some way, sort of a softer form of feedback that might impact the physical environment. And then there's sort of more harder forms of feedback that might be more about building automation and optimization processes. Think about a digital twin that's been created, and you have a bit of automation running on it that's making kind of prediction or is helping to automatically adjust environmental controls or take other action using things like machine learning or other technology concepts in artificial intelligence, right? So it's really this feedback loop that's important here to take away. But of course, the theory and practice of this is not exactly linear or completely aligned. We have a lot of ideas of what this idea of a digital twin might evoke. This sort of seamless interaction with data and kind of the interaction Minority Report style. Giving my VR goggles and AR goggles and my dashboard and let me interact with it. There's that kind of suggestive nature of the digital twin, but then there's also sort of the practical reality, is that the stuff is not exactly off the shelf. I mean, there are solutions out there and there are components of solutions out there, but for us, the sort of meaningful implementation of a digital twin requires capability in data management, wrangling of resources, guideposts of why you need that resource and how it will be used. All of this stuff is, can get really specific to the context of any given use case or organization pretty quickly. We also think about, if we look at the building design and construction industry, moreover, there is a digital literacy gap present in many organizations. We kind of knowledge, know-how beyond kind of more conventional IT setups, and among staff beyond kind of the use of CAD and BIM technology. The kind of literacy needed and the kind of knowledge and skills needed to kind of produce a meaningful digital twin aren't necessarily present. So we're going to be looking at how you can maybe get started on this. And there's a bit of a mask off opportunity here to really look at. What we believe is that the digital twin concept is achievable with readily available technology and well-established computer science and data management concepts. And so one of the goals here is to really, again, take that mask off of the digital twin and discuss some practical strategies here. And here you have a kind of the Scooby-Doo meme of let's see what this digital twin really is. And, we can start to really unpack, components of data warehousing, uses of object data, refresh rates and all sorts of technical concepts. So kind of drilling into that a little bit, what does the infrastructure of a digital twin look like beyond the kind of, two arrow feedback loop diagram? And what do we need to consider along the way as we build up to our proof of concept here and use case that I'll be discussing? Well, first you have, this kind of distinction between digital and physical. The physical building may very well be, have a variety of different data sources. And one of the common data sources that is often discussed in parallel with digital twins are, the Internet of Things and this idea of sensors in a building and, management control systems that can report current state of different things. But enterprises that occupy a building may have a variety of different data sources available that can reflect on the current operational state of the building itself as well. You have the availability for kind of more modern buildings, perhaps building information models that, have content and assets contained within to kind of give a spatial context to the building. You have, enterprise management systems that I kind of highlight as an example here, Deltek, that's giving you kind of ideas of utilization and time tracking and activities being taken on by employees. You have FM systems, which is like facility management software. Archibus is another example. For example, it's giving you kind of idea of work orders and maintenance activities that are occurring in a project. There's forms of content management system, and there's also just sort of the miscellaneous data that employees and managers may have that they're using to kind of track different things on a kind of more local granular level. And I think all of these kind of data sources can be used as a way to create a meaningful kind of digital twin solution. It goes beyond just sort of reporting, real-time sensors. It can really be used to combine different data sets to provide a picture that is of importance to the organization, right? And then the question becomes, all right, well, how do we start to take this kind of raw collection of data and use it for the purposes of really painting a more comprehensive picture? And the first step to this is really evaluating those sources and understanding how you're going to validate these things. How does the data meet a quality expectation? It's a really important question. There's a lot of data out there, but is it quality data? And so there's that kind of bigger question of leveraging the information that's available to you and ensuring that it's going to yield good insight. How is the data going to be governed and sourced? how is messy data, and can messy data that we're using be remediated or cleaned up in some way with through data survivorship protocols? And then the questions of like, how frequently is this data actually refreshed? Does it give us enough refreshed information over time that we can rely on it to understand current state? Some data sources may be refreshed on every minute. There's some data sources that might be refreshed every month. And maybe even quarterly or annually. So understanding those kind of moving parts is important. But once you have the sort of handle on what you're sourcing, you can start to implement some really, I would say, well-established data processing methods. Here we're articulating kind of the use of almost like a use of a data warehouse type of strategy to formulate and consume this data. And what we're ultimately trying to provide here in this diagram is this idea that we're taking the raw data, we're processing it, we're using a commonly used set of tactics involving extract, transform, and load, which are common to many data warehouse solutions, to process this information into a kind of more comprehensive, consolidated data set. I like the kind of data warehouse kind of alignment with digital twins in certain contexts. There's other kind of back-end considerations you may look at, like a data lake, for example, if you have a higher volume of highly unstructured data, for example. But I think in the context of what we're talking about in our experience, I like the concept here because it's a very mature technology, and it can capture historical data as well as kind of more current data as well. So you kind of get a kind of really well-structured kind of experience with it. And then you have, this idea of a really well-curated data set that you can use and access and provide a way to serve it up to your users. And so the curated set, using something like an interface, like an application programming interface, allows you to then serve this data up. So this is kind of the back end, right? This is like the infrastructure that kind of allows you to curate and compose what we might call a digital twin. But the way that this gets presented to the users involves some front end, a user interface. And here is where the opportunity to really have a curated experience can be really interesting and kind of give the digital resource some legs among users. So user applications may involve a dashboard, or might involve like an application that helps you provide feedback to the system. I think there is a kind of a big misconception, especially when you read the literature. Sort of digital twin is always sort of this sort of singular thing. And it kind of ignores conceptually the sort of idea that there are multiple use cases for them. And one digital twin may serve multiple use cases. And so you're wanting to build up these applications to provide really purpose-built experiences for specific users. So your facilities manager may need access to certain data. Your executive may need access to certain data. A staff member may need access to certain data to make decisions. And it really comes down to the idea of feedback then as users are presented with this information, and if you have a clear understanding of who the user is and why they need information about the twin from a digital twin setup, that ultimately this hopefully leads to some kind of action, some kind of feedback and optimization that can make that physical product better and continuously improve on the physical environment or product or building, right? Which leads us to sort of why do this? What we encounter often as consultants is the phrase, well, we're doing things today because it's the way we've always done it. And it's very hard to get people to change processes and behaviors, and certainly new technology concepts like digital twins or machine learning or business intelligence lend themselves to certain forms of change. So we always like to kind of bring it back to, so why would you make a digital twin? Well, we believe there's value in having centralized, up-to-date data about a facility and its sort of relationships to different systems. If we go back to one of the kind of areas of pain that we often encounter and we see out there is the lack of centralization of data and kind of the inability to correlate and curate single sources of truth. And so this concept, I think, can really lend itself to, providing a solution to that space, and kind of solving that problem that is so prevalent. There's also an idea of democratized access to data. And, if we look at a project, any given sort of architectural project, where we look at kind of facilities management systems and the process of operating a building over time, you have, different stakeholders that have access to certain data, and there's quite a bit of information asymmetry that might occur because there are different data owners, there are different kind of relationships that are there that aren't exactly clear. And if you kind of take the effort of, really building up your twin, you can start to create views of that data that can give more people access. And by giving more people access, you can start to develop and curate more correlations and get more input from stakeholders and derive more insight from those patterns and trends. And, I think that the other kind of form here is there kind of inherent waste in current procedures and processes that a digital twin might surface that can lend themselves to optimization and different forms of automation. But, I think the kind of upside here is the kind of the larger digital transformation. And we start thinking about centralization and democratization of data. We're really talking about how this impacts people and users. And, I think thematically here, one of the exciting aspects is that we're equipping stakeholders across a supply chain with data, common sources of truth that they can help them make decisions, and it can be leveraged by experts and non-experts. And I think that's really where a lot of asymmetry in today's world of technology and kind of data-driven methodology is sort of the distinction between, oh, you're a technologist or you're a data person, you have, this kind of role. But data itself has impact across your general staff, across executives and managers, right? So all that is to say, we're leading up into a narrative here about the built environment and how and what a digital twin might look like in the built world. And as I kind of indicated before, there are digital twin technologies and adjacent technologies and solutions, but it's, kind of, I would say, still in this sort of stage where there are many different pieces that can be fit together to tell, different stories with this. And so I'm going to kind of set some context here and lead into a prototype or proof of concept that, helps to illustrate this. So I indicated earlier that, building design, construction, and operations has many data sources available to it. And all too often, the promise of a data-driven paradigm becomes elusive due to siloed data, changing ownership, responsibilities, and decentralized supply chains. One of the attempts that we've seen, in the last 20 years or longer, really, is the sort of positioning of building information modeling. BIM has this sort of promise inherent to it that, by going down a route of modeling and having models that are coordinated and used as a basis of collaboration in building design and construction, that it can lead to more centralization over time. And I wouldn't say that has happened exactly. But there certainly is more there than perhaps in sort of the CAD-centric world. But what's interesting, I think, at this moment is that because BIM is so prevalent in production processes, and there is now a discussion, and it is now common to start to see models being used, more common seeing models being used after the construction process and have some role in the operations of a building, that it kind of positions itself as an interesting digital asset to leverage. But one of the problems of this asset is that it is point in time. It is reflective of object entities, data about objects, and rarely does a building information model maintain dynamic and real-time relationships with systems that extend outside of, the entity's kind of definition and the kind of the relationship from one entity to another. So, the model may have relationships between the floor and the desk and the wall and the door and things like that, but it won't necessarily have relationships to occupancy information or or data about the interior environment, or information about employees and maintenance schedules and things like that. So it occurs to us that there is this opportunity, though, to kind of start linking building information models to these other systems. And one of the things that I've covered in past lectures, past webinars for Proving Ground, is the use of business intelligence and other information based technologies that can allow us to access BIM and correlate it with other systems. So one of the things that we like about business intelligence is that it provides tools and workflows for relating data sources together. And here is an example of taking spatial boundaries out of a building information model and combining it with data about cost and revenue and occupancy factors that could provide a property manager or a developer or an owner with views of available space and give them insight into trends on how their space might be used. And this starts to get to, again, this kind of view into a model that goes beyond a static point-in-time representation and starts to give it this combine the asset with data feeds that reflect real-time or up-to-date information about the current state of a facility. It might also take the form of combining a model with analytical data about the environment and giving managers of a facility or a designer that is going to be kind of taking part in this facility's expansion, or is looking to kind of get data about trends in facility performance, information about the model in combination with again, that's sort of more ephemeral real-time data that's coming out. And from a construction process, one of the examples that we see of digital twins in the kind of construction world is understanding the state of the job site and kind of what is being done currently on the job site to build a building. What's being installed, what's the schedule looking like, and so you have this concept of a model being intersected with timelines of construction and state of the construction job site over time. So this kind of leads into sort of setting the stage for what I've prepared as a practical proof of concept. What is the how can something like this be composed? How do we start thinking through the availability of data streams and feedback and creating views of a digital twin and really start to orchestrate and wrangle, potential data sources that are out there? And so, this is a kind of a small example. I mean, I'm not looking at a massive healthcare complex or a high-rise tower. I'm really looking at a small building with 25 occupants. And I think one of the things that's kind of very apparent here is when you really start to drill down into the nuts and bolts of what's possible, is that even small projects have this kind of opportunity to leverage data and concepts surrounding digital twins in novel ways to deliver value, right? So here we have a 25-person office environment, and we also have in parallel with it data feeds representing employees, occupancy, environmental controls, maintenance schedules, and company organizational structure. And we have a building information model that kind of represents the kind of make, the shape, and the spatial kind of relationships of this. And here what we're aiming to do is take those data sources and go through the process of figuring out how these data sources relate to each other. What is the way with which we can present current data? And then can we leverage historic data that's being collected to kind of provide some insight and trends? And so these are the kind of 5 or so data sources that we're really working with in this proof of concept. And we'll be building views and understanding correlations between them as data changes and evolves. You also notice that I've indicated kind of a bit of a not only do we have these data sources, we also have refresh rates on this data. So understanding that it's not enough perhaps to have a lot of data, historic data, but there also needs to be an understanding of like, well, how often are we actually collecting occupancy information, and what's that feedback loop? How often are we able to get environmental data? Maybe it's every minute on the environment, but from an employee organizational structure, maybe that data is only really refreshed monthly, or when employee turnover happens, or when, roles change, right? So again, it's not a one size fits all situation. We're having to kind of balance all those factors together here. So as an exercise, what I thought would be interesting to talk through here is, from a proof of concept, looking and exploring some of these relationships. Here is a composed relationship that takes the facility data, i.e. the BIM building information model, and correlates it with employees and their department organization within the space. It's a very simple relationship, but it involves taking the data feed about kind of enterprise resource planning and administration of the space with the facility model, and you're able to then get a correlated view of those two things in 3 dimensions, and with color coding and graphics to kind of suggest how that's happening. And you're getting kind of a view that maybe you didn't have previously. Before, you're just seeing the model, and on the other hand, you're just seeing lists of employees and how they work and what their salaries are. And now you're seeing them together. We can take that dimension even further by looking at, okay, well, we have facility, we have the 3-dimensional facility, we have the employee, but what about the employee's behavior? How do they use the space? How are kind of teams working together? How does occupancy happen over time? So here you have an occupancy feed and a history of employee occupancy over time. So you can start to look and understand trends of how the space is being used. What teams are occupying the space? Where are they in space? And then, when do people arrive at work? When do they leave? Where in the space are they located? And when do they take breaks? When do they go to lunch? And things of that nature. How do calendars between different employees align? So you can start to understand that kind of use behavior. And then kind of moving that further forward, we can layer in environmental factors to kind of understand the user's experience with the environment. So not only are we understanding employees, how they're situated in space and their behavior, how they're coming and how they're going, but we can understand environmental factors through environmental feeds. So taking the idea of, like, okay, what's the temperature like at any given point in the building and where these employees are located? What's the level of humidity? What's the lighting level? And do these start to then contribute to calculations of predicted mean vote, which is the kind of a metric for representing human thermal comfort in the space. And we're now, by having these data sources aligned and correlated with each other, a manager can go to a report like this and kind of understand, okay, how's my team doing? Are they comfortable in the space? Is there a correlation between productivity and level of comfort? Is there something that's malfunctioning with the building control system, or is there something we need to fix with the environment? It might lead to that kind of insight as it relates to the end user. And this kind of layer of information might then extend to maintenance and how we start to connect into different equipment schedules. So this is, again, using that same facility model and intersecting it with equipment maintenance schedule on the IT front. So here you can see in red items in the office space that are set to be retired, so out-of-date computers, and we can click into them and also see what their maintenance history was like. When was the RAM last upgraded? When was a mouse replaced? When was this desk needed to be leveled? Was there a need to repair a door at any given point in time? And what's that history? And those sort of maintenance feeds, what you might find in a place like FM Systems or Archibus, and sort of those maintenance schedules and maintenance activities might show trends in the space that all of a sudden, now that we have these correlated views, are less about reactionary maintenance, and they might be related to more predictive maintenance. Like, hey, I know this piece of equipment is always going to fail or is always going to need repair at timed intervals. Now we can kind of anticipate this and plan our actions around them. So kind of taking it forward, then I wanted to maybe look at this in kind of more of a holistic way, and maybe as a way to illustrate this, I can jump out into the live dashboard. But I do see that a question came in. How are you ensuring that your model and spatial model is up to date with the as-built reality, and how do you ensure that the model stays up to date? This is procedural. This is a process-related question. Now, there are technological answers to this. Like, you can say, like, oh, well, we have, for example, technology that allows us to go from a model into the data environment in a pretty seamless way. So we can take the data and geometry inside of a building information model and export it to a data environment and have it consumed in these dashboards. So long as the updates to the model are happening and those changes are being submitted, the dashboard is going to be reflective of the current context. But if you don't have that technology in place, or you don't have someone that's responsible for overseeing the state of the model, then things become out of date pretty quickly. That goes back to maybe the human-centered component to this. If you don't have it really requires you to think through. If refresh of a model is important, then you have to think through the people, technology, and process conversation. Who's responsible for it? How is the model going to be updated over time to reflect changes? How do changes to the model become validated and entered back into the system? So, there's quite a bit to kind of take on there and think through. You might have, in kind of an automated fashion, if we needed to swap out one of these desks, and there was a sort of a sensor that was attached to the desk, and someone's able to scan QR code, scan out a desk and scan in a new desk, for example, that might lend itself to some form of automation where there's sort of automatic content swapping in the model. So I think it really comes down to the nature of the change, involves people, coordination, and sort of the definition of process to kind of maintain these assets over time, just like any other system, really. But I wanted to jump out and kind of show that, I've showed a lot of Illustrator diagrams, I've showed some video animations, things like that. This was the POC that was put together for this particular lecture. And there are a few things that are, I think, important to highlight here. It's using existing technologies. We've curated data into a set of curated various data sources from anywhere from Excel to databases to data feeds itself about kind of environmental conditions that are publicly available out there, and composed, in this case, this is a Power BI dashboard, and this dashboard is using common widgets and components to sort of synthesize a view of this information. This is a three-dimensional viewer that we at Proving Ground have developed called Tracer, which allows for the display of building information models inside of a Power BI report. So we're leveraging that technology and composing this type of experience to answer questions that we may have of the data, right? So we have our who works here? It might be one question, and what are their different roles? What's the head count by department? What are the areas available to each department? What are the average temperatures, indoor and outdoor temperatures over the past year? And what is currently the average predicted mean vote? These are views of the data that are being pushed forward from the underlying data sources, right? So if we were to drill down into any one of these, let's take a look at the occupancy report. Being able to click in and compose and see a composed view of that occupancy information that I previewed earlier starts to suggest, okay, well, now we can start to interact here and kind of get a take on, how the behaviors of different departments are occurring. We can kind of extend the timeline out and understand kind of historical trends at an interval that we're interested in. We can drill down into other kind of users and departments and understand what they're doing. It provides, again, this is like kind of one of those examples of a user-facing application that's being built on top of the infrastructure to provide some kind of insight. That one might be more about department management, as opposed to something that is like the maintenance reporting, So someone else that might have very different, this might have very different very different use case, but uses a similar set of digital assets. So, again, the arrangement of objects and the model in space, and we can see the sort of history of different objects. So the building information model object tied to a maintenance history and equipment lists that might be kind of present in a facilities management system is very much active here. I do see a question coming in. Are you hoping that case studies like this will convince clients to purchase and use sensors, IAQ, occupancy, or what strategies would you recommend to convince clients that post-occupancy information like what you're showing is valuable to them? Privacy issues aside at the moment. Yeah, and there are, of course, privacy issues associated with certain things. I think that's really an important part of the data-driven narrative is security and privacy for sure. So what we're after, I think, in this particular context, and case studies like this and demonstrations like this, is, first of all, as I indicated, we wanted to take a concept like digital twin and demystify it a little bit and kind of provide a little bit of kind of tangible backing, so kind of we can have an understanding of what we're talking about and have something that is kind of very much tangible that we can latch onto and show and talk about beyond the kind of marketing hype or the kind of theory, right? So that's kind of one goal of this, is kind of an educational piece. And then kind of a decision on whether or not it's valuable or not comes through kind of an exploration with a particular client. So one of the things that we do from a consulting perspective is that sometimes someone will come to us and say, hey, we have this inclination that a digital twin or a business intelligence model or a data warehouse is valuable to us. And we see that there being a need for us to kind of start to implement these technologies because it's so hard for us today to access data that we have, right? And so the strategy then comes down to, okay, well, let's look at what you have and what you're missing. And if you're missing a key thing that you think would help you realize a certain decision point in a better way, then let's work backwards from the problem. So for us, it's less about sort of trying to sell a concept or a solution before we understand the problem. We use these types of things as talking points to ask questions about what the problems really are, and then we can kind of work backwards to it, work backwards to a solution, or work forwards to a solution, given, depending on how you kind of view the problem solution life cycle. There's very different, I think, opinions on, should solutions come before problems, or do problems come before solutions? And we're very much a problem solution oriented group. So, the idea of, occupancy data and like on monitoring occupancy over time may solve a very particular problem. Or, monitoring your building control system and tapping into any available APIs, lighting levels, smart light bulbs are reporting on and off conditions in a space, and it's sort of a smarter facility. Maybe that tells you something about lighting levels and kind of relates back to like, hey, we don't think our employees are, having the right experience in the space. Does this help contribute to something? Yeah, who are the key sensor manufacturers? I'm probably not thanks, Martin, for that question. I'm probably not the right person to answer that. I'm not totally in the world of who's manufacturing sensors. But I will say, we did anecdotally, we did like an interesting kind of summer research project for our own when we had a physical office space. We actually don't have a physical office space today at Proving Ground, but when we did an interesting kind of proof of concept occupancy monitoring rig that basically used an HD camera, OpenCV, Arduino, and a Raspberry Pi, and we were able to kind of cobble together something that monitored the occupancy at basically every minute in real time for under $50. But we're not in the sort of manufacturing world, and that might require a little bit of additional research. Sean Foster, the promise of digital twins seems to be based on the owner-operator requiring a data-rich BIM deliverable or data warehouse in their contract language. What are you seeing in the industry around owner-operator requiring these deliverables and having to use maintain the deliverables? I can speak to that on a few levels. We have a number of, as a digital design agency, one of our client types are owner operators. And there are a handful that we're working with currently that are in the process of reconfiguring their contract method. This didn't seem to be seem to be a trend up until maybe 3 years ago. But there definitely is I don't know if it involves in the clients that we're working with currently, one of which involves a kind of medical center campus, another one that involves a massive technology organization, another one is a major retailer. There's changes in leadership that are occurring out there. There's kind of new skill sets being introduced to these teams. And so there does seem to be a trend where owners are starting to actively change their contract requirements to require certain BIM deliverables. We have seen kind of, for example, data requirements starting to come out, which we've helped authored in some cases for, if a model is going to be exchanged or passed on to the owner, what data points should be included so the owner could more readily consume the model into their facilities management database or their kind of data warehouse concept. So it is happening. We haven't done a survey to talk about how extensive that is. I would suggest that it's maybe not as widespread as the technology narrative would make it seem, but it is kind of happening in some key clients, and we see this happening in a more regular manner that is compelling and kind of giving some level of prominence to this workflow and concept. I have a concept from Stephen here, or a comment from Stephen. What are your thoughts on the potential privacy concerns? I'm thinking along the lines of real-time monitoring of user activity and interaction with space. Would this data change the way people would naturally behave in the space? And also potentially lead to negative organizational or business management practices. How does the data obtained from office buildings become democratized to help designers create better proposals? There's a lot to unpack in this comment, but I think Stephen, you bring up some really good comments, and I might even ask Steve on the call here, who's a colleague of mine who's always volunteers to help moderate these sessions, to chime in as well in terms of what he's seeing in different contexts. But the way I see it is that there's always duality to technology. We see it everywhere. And we actually did a podcast about 2 years ago on this very subject, about that kind of digital data security and the duality of technology. So a lot of it comes down to intent. I think a lot of it comes down to the how responsible we are as citizens and business owners related to this. So yeah, there are privacy concerns here. As buildings, I feel, as buildings become smarter and more connected to the internet, and you have different data streams and kind of more robust enterprise systems, you have potential data leaks that can occur, or hacks that might happen. And so, you want to make sure that as you're implementing these smarter strategies, that you're combining it with robust security procedures, that you're keeping systems up to date and patched.
I think
go ahead, Steve.
There's certainly, when it comes to privacy concerns, it's sort of like, what data are you gathering and how are you using it? There's probably some means to make sure you're not identifying any personal, individuals by looking at room bookings and the calendar system and sort of scrubbing that data just simply for, was this room used or not? And then certainly other sort of things that can imply occupancy, like the lights are on, And so there's probably ways around, maybe more passive ways to figure out how a building is being used. And then certainly more direct ways, like if you're following people in a room with their cell phones, like, that's probably a little bit more of an invasion. But beyond that, it's also how you use that information. For one example, if you have an owner that has a lot of corporate office space and simply wants to understand the design change and how that's affected the use of space and behavior and success of a space. Let's say an architect helped this owner to move from, to a small huddle room that fits 2 people to a larger conference room that fits 4 or 6, because people found through analyzing the data, people feel more comfortable in a larger room and choose to sit in a larger conference room than a smaller one. And then having that information available after that sort of design change and that physical change to create that feedback loop to say, in general, it's not that Sharon loves that room. It's that in general, it performs better because it is larger. And so I think that's one way to think about that concept, where it's how in depth or how personal is the information you're capturing, but how are you also using it? That plays a part in this.
I also want to use this as an opportunity to say that and this is actually kind of a fun factoid about the dashboard that's currently being presented on screen. From a a privacy perspective, these people in this POC don't exist. They're all the faces have all been generated by an AI face generator, and the names randomly generated, but assigned to a real world data set. So there is a kind of a level of anonymous reporting here. So I did want to highlight that kind of fun fact from a POC perspective. That's what's happening here. There's some pretty fun websites called, this face does not exist. And it's like AI generated faces. And so I use that to create my a data set here of some offices and give some tangible or some people to align with a post-occupancy data set for this. Claudio had a good question here about does this kind of tool have limits in terms of model, data, and scale? Instance, big city hospital, university pavilion, should the model be separated in smaller parts? I mean, it's a great question. It comes down to use case and resolution. Would you have a single view displayed in a web platform that has a giant city hospital with every bed modeled present in a single view? That might get pretty heavy in terms of kind of hardware optimization, but might you have different levels of model? I think there's and there are correlated levels of model. So you might have, if you're looking at things at the kind of bigger scale, you might have a kind of a massing model that shows certain data and certain levels of feedback. And then as you get into, say, a hospital's patient room and you have equipment and things like that, that might lend itself to kind of another model being pulled up. So I think there's like some, there's fundamentals there in terms of, presentation of data and making sure you're pulling forward what's most important. Because, there are limits to kind of hardware and software and representation and things like that. So, it kind of comes down to the data curation strategy, for example. I did want to highlight a few kind of final thoughts here as we close out the talk. We're already at an hour. I can't believe it. Just regarding implementation and a couple of maybe key takeaways to look at and maybe kind of inspire some folks to think about how you might go about using this, and maybe summarize a few points as we go. So on the implementation front, we have, again, this diagram, right? The kind of the physical, the digital, and the various data streams and feedback loops that are occurring. Things that we're interested in and that we are kind of working on and kind of wrestling with and kind of furthering are things like, looking at data warehouse strategies. And I think more specifically, ways with which data can be curated and mobilized in a way that can construct a valuable and useful digital twin, right? So I think there's work to be done. Everyone, if you're interested in this concept, thinking about, okay, if I had something like this, how would I use it? And what are those use cases? And then in order to support those use cases, what data source or sources do I need to really make those use cases work? And along with those data sources, there's concepts for, okay, well, how do we maintain standards for those data sources if we're procuring information from outside resources like architects or engineers or builders? Do we start to specify how that data is coming into the digital twin? And are there then tactics that we can then use those data sources like ETL and the other data processing mechanisms to kind of ensure that we're creating the curated data set that we want? So those are sort of 4 key implementation points. And there's very well established solutions out there for data warehousing and technologies out there for that concept. The other one that we're interested in is uses of business intelligence technologies. I kind of indicated before that there's no one size fits all to these concepts and tactics, right? You have different solutions out there. You have different user needs. You have different reporting requirements. One of the things that I covered in a previous lecture on business intelligence is that how agile this paradigm is for constructing views that might be important to you and constructing reporting and interfaces that are important to your use case. Everything that I showed when it came to this particular dashboard that's kind of being run off to the side was composed in a business intelligence environment using conventional user interfaces. I didn't write a single line of code to compose it. And I was able to go from kind of data source to a web viewable report without looking at HTML, right? It's kind of amazing what this type of paradigm is introducing in terms of not only democratizing the ability to compose reports, but construct reports that are going to be meaningful to your particular use case. And then another area that we've been very much interested in and are pursuing is, what are the optimization feedback loops like, and what kinds of things can we really do with machine learning and AI to construct ways of getting feedback and data and creating predictive models, and then aligning them with, I think that the key bit here is the key performance indicator. If you're really trying to introduce a feedback loop and use automation, you should have probably some idea of, what the upside of using that system will be in the long term and what kind of objective you're trying to hit. And I think ultimately what we're after here, just in a high level, from a high level perspective, is this idea that returning to our mission is that we believe that we can utilize concepts like digital twins to equip stakeholders in architecture, engineering, construction, and operations with data and insight. And these topics can lead to better built environments. And I think we can all agree that the challenges facing the built environment today, whether it's environmental, whether it's related to kind of the pandemic and other factors that are really changing the way that we work, these types of systems can have an impact on how we think differently and operate our spaces in the future. So we're at time, and I want to be kind of cognizant of that. I'm sure we could kind of talk about this for another hour, but if you're inclined to kind of learn more, or talk to us a little bit more, visit our website. We're making tools, we're kind of providing services in this space, and I think in particular, we're creating a lot of really fun stuff around business intelligence and enabling users to leverage BIM data in new and novel ways. So thank you all for your time, and this will be recorded, and we will be putting this up on YouTube, and everyone that signed up here will be getting a link to the YouTube presentation. So feel free to reach out if you have questions. If we didn't get to your question, happy to take this offline, and I'll keep everyone informed on when we have another one of these sessions to cover some new concepts. Thank you very much.
Thanks, everyone.